Good. Hello, everybody. Welcome to this morning's discussion panel on errors. We're a little bit late. These are the errors that happen in real life. Taxis don't arrive on time. People make mistakes. And we're going to try and explore the landscape of errors over the coming 2 hours. First of all, by a number of presentations by different experts in different areas, from sociology to philology to science to dreaming. And then we're going to have a discussion, a panel discussion, trying to address the different topics that will be raised during the presentations, but also some other topics that have not yet been, that will not have been discussed at that point. And I'd like to give an introduction from a hardcore natural scientist point of view about errors and error categories, an attempt at sort of mapping the landscape. And if I look at, oops, why is this, there we go. If I look at what errors are in science, in physical sciences, then there's a whole range of different topics that can be linked in with errors, starting with the standard error bars and uncertainties of a measurement that are crucial in understanding what a measurement means, to honest errors, and I'll say what I mean by that afterwards, to delusion, sloppiness, failure, crackpot theories, and, of course, outright fraud. And I'm going to give a few examples for each of these. Error bars are basically defining how well you know a measurement, how well you've measured something. If you give a number, you have to know how uncertain this number is. Otherwise, well, you're talking about fish stories. How big is a fish that you've just caught? This is an important aspect of science. Without error bars, without errors, without uncertainties, measurements make no sense whatsoever. But these error bars only tell half of the story, because if you look at the historical evolution of some of these error bars, the measurements that they represent should always be the same thing. This is one of the founding myths of science, that you're measuring the same thing again and again and again, and the same answer comes out each time. Well, if you look at the evolution of these two measurements over decades, you'll see that this doesn't actually correspond to reality. In reality, there are differences. You measure something differently than the previous experiment, you get a different result. And that's, of course, going to mean that the results that come out are different. But it's worse than that, because if you look at these curves, you actually see that there's a pernicious effect. When people measure something, they always refer themselves to the previous groups. And they're biased in what they're measuring by what the others have measured before. And so the average value that they're measuring sort of creeps away over time. You don't have a pure measurement, you always have a measurement that has to contain the history of everything that's been done before. And of course, that's even assuming you're doing things right, but you can do things sloppily. A lot of scientists work as precisely as they can, others maybe not quite as precisely, and so you end up making mistakes. And there's a number of errors that have been made in science that have not led to something new, but that are just simply wrong. There are just two beautiful examples, N-rays, which were discovered at the time of the discovery of X-rays, microwaves, a whole bunch of different new discoveries. And this was yet another set of measurements, which unfortunately could only be seen by French physicists. They're the only ones who were ever able to discover this radiation. Prosper Blondeau has spent his life and his reputation defending something that actually wasn't there. And the same thing with Nikolai Fedyakin, who discovered a new form of water, polywater, a dense, more viscous form of water, which also turned out to be just lab impurities. Nothing more fundamental than that. Of course, you can also fail, and you can fail horribly. You miss a Nobel Prize, which is sort of the best thing that can possibly happen to a physicist. The Joliot-Curies, the second generation Joliot-Curies, had seen a signal that they misunderstood. They believed it to be something different, and another person, Chadwick, reinterpreted those observations correctly this time and got a Nobel Prize for it. He discovered the neutron this way, something that the Joliot-Curies missed. Crackpot is also often linked to error. You can try to propose new ideas like the concept of archaebacteria, a third type of form of life, which is what Carl Woese did. He proposed a common ancestor to all organisms, the archaebacteria and the extremophiles, which was considered to be completely wrong by the whole field at that time. And of course, like many cases in the past, he was right. And over time, luckily for him, this was recognized as being a correct model. But there are many other cases where this isn't the case, where a crackpot idea is a crackpot idea and it doesn't deserve to be pursued further on. And then finally, there's the category of fraud. Mendel is one of the famous scientists in history for having discovered the heredity of genetic traits. Well, it turns out that this is a fairy tale. It's not actually true. His data were incorrect. They were falsified. They were too good to be true. And it turns out that probably he had the right idea, but the wrong data, the wrong proof. He falsified his data in order to reach the conclusion that he knew was right, and that turned out to be right as well. And I'd like to give a few examples of other errors that are perhaps known, perhaps less well known, in different areas. Cold fusion was discovered to great fanfare in the 1970s. Chemists managing at room temperature to fuse atoms of hydrogen and to generate energy. Vulcan, a planet that is invented, predicted to exist very close to the sun to explain why Mercury's orbit didn't behave according to Newtonian gravity. Mars canals on Mars, seen through telescopes, and the theory of continental drift by Wegener. And all of these are errors. Cold fusion was a measurement error. Vulcan was a hypothesis error, an error in what was actually assumed to be correct. Mars canals are an observational error, and continental drift is an error in explanation. The model was correct, but the explanation that he gave was incorrect, and that led to him not being taken seriously. So we're going to go well beyond science and art today in the topics we're going to discover. So we're going to look for a landscape, a map. And when you're heading out to new territories, it's always good to have a map. And the worse your map is, the more interesting the landscape you discover. If you're going to discover the continent of the Americas, it's great to have a map that tells you that on the way to Japan, there's an island called Antilla where you can furnish yourself with water and food, and that Japan is actually much closer than you could have known at that time. And on the way, you're going to discover something completely unexpected. So errors lead to two things. You can have success, or you can have failure. And we're going to talk about failure as well. And before giving the mic to Hiroshi, Hiroshi, yes, I got it right, sorry. I'd like to leave a quote with you, which is a motivator for why we're doing things. As scientists, we're always trying to go beyond what we know, and we're always running the risk of failure. So I want to leave this statement with you before passing the mic to Hiroshi. Thank you. So Hiroshi, you're next. And I quickly have to say a few words about Hiroshi.
Yes.
As introduction, he's professor of media arts and sciences at the MIT Media Lab, and he's been running the Radical Atoms exhibition since 2016, which is one of the things he's going to talk about.
Thank you, Michael. Good morning. Ich heiße Hiroshi Ishii, and ich freue mich, Sie kennenzulernen. I spoke ambition, but anyway, let me speak in English. And it's a great pleasure to coming back to Ars Electronica because always we see the collisions, fusions of very different paradigms. And I'm very excited about seeing the theme like an error or perfection because that seems to be a bit kind of the illusions because error assumes there's something correct. So error goes against norms. So existence norm is not necessarily always true in this world. So perfection, also very strange, because perfection is a kind of the illusions driven by the unquestioning belief in the norm. There's no such thing like a perfect in this planet because so many different value systems. That's the whole reason we are here in the links. The collision, discrepancy, difference of the viewpoint is something so important. And also underlying every norm, there are central dogmas. So as an artist, I think we have to redefine the gravities or dogmas, because dogma really make our scope very narrow. So one of my messages, which is very different from my introduction, I'm not a hardcore scientist like Michael's, but it's more like a soft design or art guy, and how to shatter dogmas and create new archetypes is something I really care most as a say, artist. One of my work is a battle. My work in the past 23 years in the MIT Media Lab is a battles against pixel empire. That's one of the dogma. Pixel seems to be one of the most powerful, fluid, dynamic representation of ideas. But I argue that's not necessarily true, because pixels are intangible, decoupled from our bodies, stuck in a 2D screen, which disembody ourselves or our world. That's the reason I started fighting against the GUI, pixel empire, still dominate this planet, but pushing materials, information to physical world, tangible. Then making materials, physical material dance. We're very excited that 2016, Gertrude Stocker took this other kind of entire umbrellas of this festival, putting a very nice subtitles. Alchemist over time. We do not sculpt using the clay given by somebody else, but we invent new clay or gold, metal, or expression, then do artistic expression, communication. That's something I like a lot. So the world has mainly two materials. This is a very simplified version, but one is frozen atoms, like this podium or plastic. These are frozen. Your chair, also inert, frozen. Second, pixel, very dynamic, but intangible. You can't hug, you can't touch, you can't taste, because it's photons, or only hit your retina. So one of the ways to defy gravity or dogma is create third materials which dance, dynamic, physical, but also computational, so that we open the door to the new communication, design, and artistic expression. So three things I care is tangible, because our body really matter. To make embodied interaction, information, idea have to be physically, tangibly. But also important aesthetics. It has to be inspiring to make people think deeper. And also interactivity is so fundamental to engage people. People have to be part of the dynamic equation. That's why I like this orari very much. How many people saw this orari in the museum? It's beautiful. Usually we can touch, that's the problem. But this is a representation of knowledge about the solar system, for example. But the important thing is interface. This handle inviting you to grab with your hands. Once you grab and rotate, all the planets circulate around the sun. But the causality change is so obvious because your body, kinesthesia, muscle, bone, neural system screaming in sync with the movement of mass. This coupling never happens in clicking mouse or pixels or just flicking the touch screen. So that's sad. But also other important things, real 3D. People can come around this orari, then talk. It's real 3D, not a fake 3D from one person's point of view. So how to bring back tangibility is something I really interesting. Then it's great that always Ars Electronica has a great press. Already 17 years ago, we had a first series of the exhibition about tangibilities, Get in Touch, showing about how important to bring body back, hands back to the interaction. Then 2016, we're given another opportunity to bring radical atoms. How many people saw this Inform in the Ars Electronica Center? Good, it's still running, third year. Mini pin is dying, but still it's alive. So hope you have a chance to go to Ars Electronica Center, second floor, to touch it. Also basically biological materials, which breathing, and all of my students. So a bunch of stuff, but always questioning these new paradigms or ideas in this community means a lot. It's beyond science or technology, how these materials may allow new expression or new interaction. So let me show one piece of the Inform, which is done by a bunch of people. Now, Professor Daniel Reitzinger, actually he was working for Future Lab many, many years ago. He's now University of Colorado Boulder professor. Also, Sean Former, he's now teaching at Stanford. Those key guys invented this new one. Can I get a sound? So basically being here and there is our dream. But it's not a video conference, but you can really capture then re-embodied in the over distance. Because it's physical, you can also manipulate the stuff, like those. So you can do a lot of the crazy stuff, but actually you can experience. So this is a object, found object, can be also physically embodied. And also you can read a book for your kids over distance. So important thing, this really changed the notion, like affordance is very designed. Also intermaterial interaction, you can push all the materials. Then 3D printing is great, but the printing is dead end because everything is frozen. So for example, so this is all the affordance stuff. Come on, okay. So these are all the numbers, but still alive computing. You can see that the computational stuff is happening to meet the constraints. So, but this also become very interesting ideas. This is inspired by the Escher. So this is a tribute to the Escher's notion of the infinite maze, but also relative movement of ourselves in this maze. So then we went to the next level called transform to make a triptych of these 3 info machine, then brought to Milano. I'd like to show a short video clip. Milano Design Week, or Milano Salone, is very famous for the festival of the furniture. But the furniture is relatively frozen and passive. Beauty is skin deep, surface. So I want to make a collision of the beauty of the machine, kinetic movement, interaction with those stuff. Looks like a furniture.
Between 2 juxtaposed concepts. One is technology and design. Another one is stillness and motion, and also nature.
Technically, sounds and pins are computationally controlled, but this is a stuff you can fully control, like a pixel in the screen, now physically embodied. You can make them dance or respond. So I think one of the important things, how to see the world. We observe the world with eyes. Long ago, 14th centuries, people invented the telescope, which really expand the view, but still they are bound on the Earth. Observatory also still bound on the Earth. But one of the amazing spike happened when NASA deployed Hubble Space Telescope. So now your eyes can fly deep space, then look back yourself to open the eye to the new dimension. So I think important things of Ars Electronica is how to really enhance and expand and also escape from dogmas to expand our views of the scope. So one problem is people could only see the world from their own perspective because the eyes are stuck in the head, of course. However, if you can make a jump like Hubble Space Telescope, you can really shatter dogmas and create new archetype. So to summarize, I really appreciate the theme of the error or perfection, but the error goes against norm. Assumption that norm exists might be questionable. Also underlying every norm, there's a central dogmas. And we are here to really fight against this kind of dogma and hope we can create the new archetype. So one last important point is art, science, technology, design has a very different value system. And, but most of us really enjoy speaking all this language, also translate your idea from one dimension to other dimension. This spiral is very important. Also, this spiral comes from Sagrada Familias, Gaudi's architects. Do you guys know it? I love it. But also I like this Bruegel's painting of Towers of Babel. I saw a small one and a big one, both in Vienna and Tokyo. So now I really see that Ars Electronica is a place that we make a spiral, art, design, science, technology, but to go to the next levels. So that is a reason I'm so excited to these panels. And thank you very much.
So thank you, Hiroshi. The next panelist is Eveline Wandl-Vogt, who is a research manager at the Austrian Academy of Sciences and founder and coordinator of Exploration Space, which supports transformation processes from the humanities. So I've agreed with Jim that you go next, and then Jim, and then Ulrike.
Okay, thank you very much. Sehr geehrte Damen und Herren, liebe Kolleginnen und Kollegen, dear colleagues, it's my pleasure to be here and discuss with you error, culture and uncertainty. I want to speak about that from a very personal position and how I define it, how I analyze it, and how we work with errors in our working group and our surroundings. If we look into a dictionary, and my background is lexicography, several people of you probably use Leo, there is a broad range on how error is defined and what is called a synonym for this error. If you even look into the Microsoft thesaurus, that offers even more possibilities on how to translate it, and an option is as well fault. So you see there is a very broad range. It's not no more just interpreting it in a positive way, it is definitely in a negative way as well. So it is not just the translation. And the translation shows us, or that what is offered us as a translation shows us what we think, but on the other hand as well how the world and society interprets error, and as well it is mapped to our experiences that we have with errors and error around it. The eyes are useless when the mind is blind, and insight is a process. But what we're supposed to know might not be a certainty. It is always related to what we define it and what we know. Error is defining us as a human being. It allows us to learn if we make use of it in the right way, and it allows us to grow. The ability to learn and to grow is the core of living itself and keeps us alive, actually. So, there is a cultural framework in which we are embedded and which defines how we are seeing errors on the one hand, and on the other hand, how we are dealing with errors and how we should deal with errors to make them a learning approach and a learning culture. To deal with errors is nothing new, actually. Aristotle was already defining disaster from error and from an evil act, and thinking about or defining it related to predictability on the one hand, and on the other hand, whether there is, or in relationship to the intent. And we are just looking into the error where we say it is kind of predictable. If you are doing something, it is very likely that you will get into some errors, but there is no bad intent, actually. You want to increase. What we need, therefore, is a competence to manage our errors and deal with those, and to deal with them in a productive way. If you are looking at a very simple diagram and look into what costs do arise with errors on the one hand, and on the other hand, what is the benefit of errors, we start to look into it slightly from a different approach. And I just want to point out two things. There are errors that are of high benefit on the one hand and of very low cost, so we should be very open and friendly towards that type of errors and try to make them happen, actually, to increase our knowledge, our experiences, and innovate. On the other hand, there are errors for sure that are very cost intensive and of very low benefit, so we definitely should avoid. But in between, there are probably the most innovative things to reach, namely errors that we are trying to risk because they seem to be of high benefit, but they are related to high costs as well. So what are we doing with that? We have to think about it, and we have to manage them in a meaningful way. The following few slides give you probably a slight insight into how we are dealing with errors and how we try to embed them as well into a research infrastructure, which means we are offering as well a framework or thinking about frameworks where errors and where challenges are already related into a scientific framework and help us to deal with that. And this is a design of an open innovation in research infrastructure in networked humanities. What I like you to look into probably is to see that we are focusing on challenges that are societal challenges as well. On the one hand, it would be as well a challenge to deal with an error and then re-embed it into the research process, dealing with all people of the society and co-design with them towards a better meaning and understanding. We are using for that approach design thinking and agile organization methods. Design thinking offers us the opportunity to address errors in a very productive way and do it in an iterative process and quickly actually get into the knowledge, seeing whether we had an error of a type of, let's say, a beneficial one and that leads us into innovation, or an error that would be of high cost if we proceed with the procedure at all. Exploration space is a virtual as well as physical platform for experimentation and innovation. So we try to put experimentation into the setting of humanities, and it was funded in 2017. It is the current contribution to of the Austrian Academy of Sciences to this open innovation in science research infrastructure and the focal point of its further development and movement. And it applies actually methods of open innovation in science that are mapped to the Austrian open innovation strategy. I'm very much delighted to let you know that we are presenting our mission in the framework of Ars Electronica Creative World 2018 in the setting of the POST dictionary, where we are teasing the reinvention of the dictionary and where we are introducing as well how we are addressing new types of working in digital humanities as a pilot. What we have learned so far is that the process is messy and we are kind of afraid of this messiness with the process. So it is definitely a chance and a challenge and we introduce and invite to work together to ease things. There is definitely a need as well to develop new skills and a new kind of openness to do so. We are in humanities anyway, and in our research very much working with heterogeneous data that are very often uncertain. And we are aiming to make this uncertainty visible, analyzable, and put it into a structured way. This is part of the scientific process, and there is a new project going on which is called Provide DH, that we are starting to think exactly about uncertainties much more than about what is certain in the research process, because we realize there is so much that is still uncertain and that is a part of our knowledge as well. So we are trying to sort out the knowledge process actually and embed knowledge management into that setting. And what we are calling here negative knowledge is the knowledge about what we have learned during the process in making errors and mistakes, and try to share that. But this sharing actually requires from us a very high degree of openness, of being aware of, being self-confident actually, and accepting that making errors is our process towards innovation. But that as well means that we are aware of just going into the right direction when we are making errors, and mainly avoid those that are of high cost and low benefit. Our goal is to make accessible this knowledge in a quick and low threshold way and open it together in a participatory process for knowledge sharing, for societal benefit. Thank you so much.
Thank you, Eveline. So I will introduce the next speaker, who is the third panelist. Matthew Fuller is author of How to Sleep, The Art, Biology, and Culture of Unconsciousness, and by the way, also professor of cultural studies at Goldsmiths University of London.
Yeah, okay. My first mistake, speaking to a microphone at this time of the morning. What I want to do is talk about a festival that we have running connected to Ars Electronica at the other end of Linz. At the moment, it's called Sleep 48, and it's a collaboration with the art space. You don't want to look at that. Sorry, this is old school humanities where we don't have any PowerPoint. I'm just going to read. And the space is the space Stadtwerkstatt, which is an artist space, an artist collective, where we're running a small festival looking at the aesthetic possibilities of sleep. So not sleep in the classical sense of sleep as something that produces dreams and therefore becomes meaningful, but sleep as an active daily practice that produces aesthetic effects, that produces experiences of the world. So is anyone here active sleeper? You regularly sleep? Okay, so this might be of interest to you. If you're asleep now, this talk is succeeding already. So what I want to do is start from a story of a scientific experiment that produced an error that enlarged our understanding of sleep. So in sleep science, a classic example of sleep would be the story of Hans Berger, who's a German scientist a German psychiatrist starting at the end of the 19th century, who became very active in the 1920s. He was the inventor of what we now call the encephalograph. Berger imagined it would be a means of scientifically detecting telepathy based on what he imagined to be psychic energy. So this is an example of kind of vitalist theories of the end of the 19th century. By looking for the existence of telepathy, he found electrical activity in the brain, what we now call the alpha waves and the beta waves. The first time the alpha wave, which is this kind of slow wave of electrical activity that connects different parts of the brain, was named after him as the Berger wave. So the story of this error is a long one. Berger trained initially as a doctor, but got bored with medical training, and in search of some excitement, he enrolled in the cavalry. Unfortunately, he got too much excitement and fell from his horse into the path of a unit drawing a cannon. He was almost killed by this accident, but luckily the other people in the army stopped their horses just in time. He didn't eventually die. But the key thing that happened was that at that moment, apparently, his sister had an immediate feeling that he was in mortal danger and got her father to send him a telegram to check that he was still alive. So remember the days when you couldn't just ring someone up? You sent a telegram to check whether they're still alive. So this introduces an error bar. You know, are you still alive at the point the telegram arrives, and so on. So Berger firmly believed this to be an example of telepathy. But he was wise enough to know that you don't have a long career as a scientist if you start proclaiming the grounding force of your experiments is a crank theory. So what he did was repress this hypothesis to private notes and began his experiments returning from the cavalry to psychiatric practice in Jena, where he had a day job as a psychiatric doctor. In the night, he would work almost in a kind of hacker-like style as an inventor and researcher. He worked for a decade before presenting his work. He discovered the alpha wave in 1924, published it in 1929, and he was regarded as a crank and an eccentric, someone who wasn't working with stable theories, stable objects, and was largely ignored until his work was confirmed by others in 1934 to 1939, where it was incorporated eventually into standard models of the brain. One of the things, as an aside for my kind of academic colleagues here to note, is one of the things that Berger early discovered in monitoring the electrical activity of the brain. He finds in his notes that making the facial expressions associated with thinking does not result in actual electrical conductivity associated with thought. So if you're faking thinking, don't actually imagine it to arise. So we've had error in this discussion as a form of misinterpretation, error as a false idea, but we can also see error as a form of translation that happens in his work. So when we think about electroencephalography, which is the putting of sensors on the scalp, and in Berger's early case was actually inserting electrodes, silver electrodes, into brain tissue, these translations become very important. How do you translate from the electrical activity, the electrical device, into scientific understanding? So alongside translation, there are findings of equivalence that are common in science. So how things become interpretable by number, how things become translated into data, and there are errors of mapping from one system of understanding to another, or one media system into another. So Berger, in order to analyze the electrical activity of the brain, had to translate it into sets of numbers, into sets of data. So Berger is able to translate the inscrutable operations of epilepsy, for instance, and a lot of the initial subjects he was looking at were epileptics who showed strong electrical activity in the brain. He translates these inscrutable operations into wave patterns that are divulged by means of harmonic analysis, such as the Fourier transform, so a quite old mathematical set of tools from the 18th century. Electrical media then mediate between mathematical techniques for transforming frequency over time and a form of seizure. So again, a third form of translation. In doing so, these electrical media were able to verify the similarity between such seizures and artificially induced epileptiform attacks induced by the use of cardiazol, which is a chemical used to treat schizophrenia prior to electroconvulsive therapy and other means, by means of a common reference point to the waveform. So the waveform that is measured by Berger becomes the thing that we treat, becomes the standard by which we then compare epilepsy, the action of a chemical that produces a waveform that is similar to an epileptic attack, and by which patients are then compared to each other. So the number, the waveform, the media systems that are used to interrogate the brain all become points of translation. So there are 4 layers of translation here. What Michael earlier referred to as error bars become very active in this point. So there are translations between number, electricity, waveforms, chemical performance in the body, and medical conditions that produce similar results but are not the same and are in different bodies. So by now we're familiar with the computational subsumption of signifying systems that are grounded in the information theory of Claude Shannon. This is a form of transposition and a general media system which allows for forms of translation. We have numerous systems that are now translated into general systems of equivalence of the computer, where one system, the elements and associative rules of medium A, can be reproduced in the elements and associative rules of medium B. And this is the classical source of error in digital media, since the functions and elements being mapped may not fit or may create an emergent condition which we can call a weird machine. And this weird machine, these kind of emergent machines that produce unexpected translations, unexpected forms of conjunction, are what we live in as a society to some extent, but also what we can test for its aesthetic potency. So it's in some of this spirit of testing the aesthetic potency of emergent machines, emergent systems that we're interested in working with the question of sleep. Sleep is very much something that we all know a lot about. We're all relatively active in it. And it's something that emerges out of the interaction of numerous systems in the body, such as the homeostatic system, the circadian system, and others that in turn arise out of the evolved interaction of the human body as it stands at the moment. So this festival that we've developed is to try and think about sleep as an aesthetic practice. So first of all, this is a category error. Sleep is a very primary activity of most species, and in humans roughly takes up a kind of third of our life. But to see it as an aesthetic or an artistic grounds is something that is a relatively novel approach. So it's a collaboration with the artist Shuli Chang and the Linz-based organization Stadtwerkstatt, whose building is next to the Ars Electronica Center. The slogan of the festival is art for sleepers, art by sleepers, and art as sleep. What we've done with the festival is to produce a sleep beer, that is a brewed beer that has St. John's wort in and stone pine cones in collaboration with Café Strom at Stadtwerkstatt and Torbrau in Ottenheim. Food that encourages sleep because it contains plant analogs to different sleep hormones produced by the chef Taro. Sleep races in which people competitively sleep, something we hope will become an Olympic sport in the next few years, which is done in collaboration with the Linz Kepler University Hospital and Dr. Andreas Kleintorfer there, where people wear a polysomnograph, so a thing that measure 12 data points of sleep, and the speed of their sleep, the depth of their sleep, the harmonic nature of the data they produce is analyzed by doctors in order to judge who slept the best. We also include working on confluences of brain activity in separate bodies by Qualia Industries. And we have 2 nights of performances for sleep by sound artists where the audience is given beds and sleeps whilst the sound is played. And we have also sleep tunnels by the group No Architects for cost-free accommodation during Ars Electronica. Sleep is increasingly by lawyers being seen as a basic human right, and sleep deprivation, as we know, is a form of torture. So production of expensive events in which people can't afford accommodation, we could say, need some kind of response to. And we have a group of rough sleepers, so people taking sleep into places that it's excluded from, such as banks, shopping centers, and exhibition spaces, and directly going to sleep in these places. So what we're interested in is this condition of multiple translations from aesthetic practices to the experiences and individual and collective experiences of sleep to biological and cultural and social practices of sleep as an emerging aesthetic form. We see this as composing a shifting pattern of mismatches and confluences of interpretation that very much mirrors the action of sleep in the body, but it also works at the level of aesthetics and of experience as an active category error that produces new kinds of experience. So we're interested, and to finish, we'll say that we're interested in an aesthetics without a classically constructed subject, so a non-conscious subject, a subject that is not awake, not alert, and not perceptually attentive or contemplative towards an aesthetic subject that is alive, alert, dynamic, composed of multiple interacting systems, but operating by different modes and registers of sensation and sense-making. In this context, error becomes a set of interference patterns between interpretative and performative frameworks and techniques and the different scales of realities that they take part in, translate, and induce. Here, aesthetics, and particularly art, is a form of direct action in sensing and sense-making that takes these multiple compositional layers, transformations, and forces into account and works with them. Okay, thank you.
Thank you, Matthew. So the fourth panelist, back to hardcore science, or semi-hardcore science at least, is James Gimzewski, who is professor of chemistry at the University of California, LA, and member of the California Nanosystems Institute. He's also fellow of the Royal Society and Royal Academy of Engineering, and has honorary doctorates from the University of Aix in Marseille and University of Strathclyde in Glasgow.
Okay, thank you. So I'd like to talk, the title of my talk is Error of Errors, and I'd like to talk about the scientific sort of sense of errors, what they mean, and then I'll talk about errors in life, in biological and also social systems, and how the concept of error is very, very much different. So I'd like to start with random errors in science. And generally, we have three types of error in science. One is called random errors, fluctuations. And the word error actually comes from the Latin word, which means sort of wandering. So it's a kind of wandering. And the second one is called a systematic error. So if you fire a gun and it's constantly off, maybe due to the air blowing or something like that, that is a systematic error. And that's quite hard to deal with. And the third one is just human error, and we heard a lot about human errors. They can be mistakes, they can be deliberate actions to try to mislead people. And when we deal with random errors, the fundamental thing we have to consider is that random errors have a particular limiting sort of distribution. So if we measure something a couple of times, we average it, we make an assumption that essentially if we measured it 1,000,000 times, it would follow this bell-shaped curve you all are aware of, right? And I show at the top right there this bell-shaped curve called the normal distribution. And you can see, in this case, it's for students. So the average mark in the class is given by the point where, there's a maximum. And then we have students with high marks and low marks. But if any of you have, analyzed your class in terms of the grades, you'll find it never actually follows that bell-shaped curve, very, very rarely. But there are examples in science, when you do science, simple experiments, where we try to reduce it and where it does work. And this is one example. So at the turn of the 20th century, people didn't actually accept the idea generally that atoms existed. And Einstein, he wrote a paper in 1905, and he showed that the motion of some dust, dust particle or something, could be used to actually prove that atoms exist. So the dust particle's been hit by multiple atoms, and it's jiggling around a little bit. This is a simulation. You can see the yellow particle moves in this random trajectory. And if you plot the way the steps it moves, not the distance from the origin, you will come with this bell-shaped curve. And it's not the position, the average position is irrelevant. It's the width of that curve that proves the existence of atoms, essentially. So that's one example where we use this kind of randomness to prove the existence of atoms. Now, there are also major errors because we use theories, okay? And then we compare them with experiment. And we, go back and forward. The theoreticians change the equations to try to match the experiment, and experimentalists change the experiment to try to agree with the theoretician. This is one example which led to the concept of quantum mechanics, quantization of energy. And what you see is a black curve. It says classical theory. And then you see the biggest blue curve. And what happened was, at the end of the 19th century, Maxwell essentially had equations that described how waves worked, like light. And Newton had a bunch of theories that described how objects like balls flying through the, or it could be molecules even, worked. And they used these theories to produce a classical theory of how radiation is emitted when you heat up a thing called a black body. Okay, so if you heat up a piece of iron, it will eventually, glow red and white. And you can see the classical theory did not fit the experimental result. And this was called the ultraviolet catastrophe. And it led, so it was a massive error. This is a massive error. But this error led to one of the most important changes in our thinking about science, quantum mechanics. And Max Planck, he had to come up with some idea. There are jumps. But he didn't like that idea. Nobody liked it, but it became accepted, and that's why we have quantum mechanics from this massive discrepancy, a systematic error between theory and experiment. So let's talk about something real now, more real, error in RL, okay? If we look at, let's say, one of the things I look at is how soft cells are. And so we took some cells from patients' lungs, and then we measured the stiffness using some nanotechnology, okay? And what we find, this is a whole bunch of different people. Some of them have metastatic cancer. Some of them don't. They have to go in every so often to check for the fluid in their lungs, pleural effusions, and we take those cells. And what you can see is if you look at the bottom curve, these are normal mesothelial cells. They don't follow a Gaussian or normal distribution at all. They follow another distribution. But you can't say the cells are in error. This is just a fundamental aspect of life, that there is a distribution. However, if you look at metastatic cancer cells from these patients, that's the curve B, what you see is it actually looks like a Gaussian. So the real good cells actually have this weird broad distribution, and the metastatic ones do follow some kind of normal distribution. Now, if we look at complex systems, and I'm very involved with complex systems, there's two types. Structurally complex systems, things like a watch, things like robots, or robots that build computers, all these things are structurally complex, but they have very little freedom of action. And so we can analyze those, and we can use this kind of concept of error analysis, the normal distribution. We can work out, the gears have a certain amount of play in them and so on. However, that applies only to really specific elements of technology and engineering. The second class of systems, which is by far the biggest, these structurally complex systems account for a very small part of our universe or our world. The other one is interactively complex systems. That is where systems interact with each other. And this that interacts with this, with this, with this, with this. And in such a case, we have a greater freedom of action. So when we do this type of analysis, the statistical analysis, the concept of error completely breaks down. It applies to networks, things like Facebook. It applies to networks like the planet Earth, to earthquakes. It applies to everything that's actually real in the world. And When we analyze those, if you look at the right as a particular scale-free network, we see we don't have an average earthquake. We don't have an average anything. We have a whole range of behavior. And this shows some of them. Modern banking, there's not an average kind of bank. There's big banks, a few big banks, many small banks. The way the US airline system works has a few very strong nodes, as many neighbors. There's no average number of movies an actors are in. Some are in, all the movies. The other ones, like in Hollywood and Los Angeles, where I am, everybody's a kind of wants to be an actor, right? Maybe they've been in one movie if they're lucky. So the distribution's completely different. And it applies to all these phenomena here. If you look at earthquakes, forest fires, solar flares, extinctions, wars, there are a few big wars and many small wars. And it follows this thing called the power law distribution. And you can't say there's any average there. This is like the powers of 10 versus the powers of 10 here. And if you look at the human brain, neurons, they also do this. So if you look at MRI, functional MRI activity of the brain, you'll find that it also follows a power law. There's not an average kind of brain activity. It doesn't exist. If you look at neurons firing in neuronal cultures, they also follow this behavior. If you look at EEG, it also follows this behavior. So the concept of error in the real world has no real meaning. There's no meaning, in my opinion. And our work actually is to try to develop a machine that's completely imperfect, a type of computer that actually emulates the brain. And this is activity in the brain, resting state, fMRI, and this is our particular machine. And it never does the same thing. I believe that in trying to look at complexity, scientists are very, very badly equipped. Scientists can't look at complex phenomena. They want to keep away from it. They hate it. It gives them headaches usually. And it is the biggest single challenge of the century to understand complex systems. And in that respect, artists have a terrific role to play because artists look at very complex phenomena and they're able to extract some kind of information from it. And this is a particular example, Birdsong Diamond, which is, I think it relates to artificial life, which involves, it was showed last year in Ars Electronica, evolutionary biologist Victoria Vesna, who's an artist, and Takashi Ikejima, who is working on these networks. And when he found that, for instance, when you have 1 million object voids, you start to get emergent behavior, and this thing starts to come alive, this life. And this thing is based on that concept. So, in summary, I would say error is a thing we use to describe what we don't understand. If we understood the very sources of what goes on, it wouldn't be error anymore, okay? And the concept of error has, at least from our mathematical sense, has little meaning in the real world because the real world is intrinsically diverse and dynamic, and the emergence of things can't be predicted. Particularly in the world of networks, interactions, and so on, it's, to me, meaningless. And the inevitable, the unpredictable, are things that arise from the interaction of objects, not the behavior of objects. The behavior of the object itself, like you saw, it follows that bell-shaped distribution. But when you put them together, you start to get something that resembles the life of the planet and our own lives. So thank you very much. And I'd like to also mention that we have Art Science Center for 11 years at UCLA. And we bring together neuroscientists, we bring together artists, engineers, surgeons, and together I think they are the future of how we're going to understand the complex world we live in. Thank you.
Thank you, Jim. So we come to the last panelist, who is Ulrike Felt, Professor of Science and Technology Studies and Dean of the Faculty of Social Sciences in Vienna. The microphone? You have it? Ah, you have the mic. Okay, you have the mic. The vicissitudes of real life interfering with what we would like to have as perfection. You'll have to bear with us. There's going to be another moment of this type after Ulrike Felt's talk, when we will rearrange the stage to bring everybody on stage at the same time.
If you want, you can do. Yes, I think there's time, huh?
Okay. We're done. Okay, thank you. Apparently, the translators got the slides, but not the machine. So thanks a lot for the invitation. As you can see from my title, I will choose a particular view on what we call an error. And I come from a field that is called Science and Technology Studies, which actually looks into how societal change and scientific and technological change go together and shape each other. And I think in that sense, it's interesting to ask how error actually has changed over time. This is definitely not a stable category. So what was counted as an error, or what is counted as an error today, was actually not necessarily an error at any given points in time. So that makes it interesting how we look at historical cases, because very often we look at historical cases with the lens from today's knowledge, and then we interpret them and say, okay, they did this kind of error or that kind of error. But of course we would have to creep into the mindset of the time and really understand why something was an error. Now, the second thing I wanted to start by saying is that Michael in the beginning showed a map. And I find it interesting when you look at old maps, and that is a parallel, you have very different kinds of maps. And what I like particularly in, let's say, 18th century, 17th, 18th century maps and earlier, you have maps that don't only show the territory, but these maps show the people that live on the territory. Sometimes they show monsters in the sea to show the problem areas that are identified. So you have a much more graphic imagination of how the world looks like. Now, science has cleaned that up in a perfect manner. Monsters have no place anymore, and also the way how we draw maps is a very physical imagination of space and distance matters. And I think that's an important thing. Now, I come from a 3 days row of talking about trust, about talking about error today, yesterday on trust, today on error, and tomorrow on research integrity. And that made me think about why we are so concerned about that. And that gave me my subtitle of my talk, The Future Perfect Tense. So is it not that we think that science and technology can make this perfect future realizable? Isn't that still the dream? I mean, we don't maybe make it so explicit anymore than we did it maybe 50 or 100 years ago, but it's still this belief that if we do science well enough, it will lead us to a better world, a different one, a full understanding of, etc. At the same time, if you would go into history and you would see how one imagined the year 2000, you would learn that that definitely doesn't work very well. Okay, so starting from there, I would like to share some ideas with you. Some of that has already been picked up. That's always when you speak as number 5 out of a row. Others haven't. And, okay. I would like to start with these 3 images. These 3 images depict why we are so concerned with error. The first is science seems to be under observation from a whole layer of things. It's under scrutiny by government, it's under scrutiny by politics, it's under scrutiny by media, and I do think that's an interesting observation. So why do we need to pretend that we are flawless? We have never been flawless, but now we have to somehow pretend that we are flawless in order to kind of keep a certain authority over explanatory power in our contemporary societies. The second does the same thing. So is our system ill? Does it have, I mean, if we cannot reproduce our results, what does that tell us? If we think we have more fraud cases, what does that tell us? And I think that brings this nice big brother image that is from the journal Science, which speaks to the ethical reviews and that we need institutional surveillance of science so that scientists still continue to behave in an ethical way. Now, that opens the second kind of problem. What counts as ethical at a given point in time? And I come from Vienna, so Vienna was leading in medicine at the beginning of the 20th century, and we did all kinds of very strange experiments. I came across some historical documents showing that there were kidney transplantation and in order to not with terminally ill people, and so they transplanted the kidney into the arm of the patient to better watch what's going on in this kidney. I'm sure there was no informed consent or anything going on. One was thinking that was for the good of science that this happens. And we thought that was totally okay, probably. And there was not a lot of questioning about that. We would question that highly today. So these kinds of values have shifted quite considerably. But we also have to think about how we imagine the society we live in. And I do think, if that works, that we have 2 different kinds of overlapping imaginations. One is that we think society improves with innovation. That is politically a very strong discourse that is here. So we need the new, and everybody needs to pretend that what he or she is doing is totally new, even though it's most of the time not that new. And this, of course, has an influence how we imagine future developments. They come through innovation. And we all live along these promises which tell us where we will move if we are ready to go along that line, even if it looks a bit shaky. And I come at the end of my talk to something of that. And the other part is that we live in a society of self-experimentation. We always have lived in societies of self-experimentation, but we more consciously ask people to engage in that. So to pick up new things, even if it's unclear where they will lead us, we say, new technologies, artificial intelligence, just go ahead. Don't be against progress. This is where we will head on. So we ask people to be experimental, and experimental always means trial and error. So there is a kind of considerable possibility that there will be errors in what we kind of implement and make. And that's an interesting reflection how we deal with that. Now, let me start to think a bit, and that has already been mentioned. Error means go astray, losing one's way, etc. So it fundamentally comes from the word errare. And I think it's important to keep that in mind, but it changed the meaning over time. And I just took 3 time points. While around 1300, it was kind of pictured that the deviation from truth made through ignorance or inadvertence. 100 years later, you find definitions of deviation from what is regarded as normal, which is yet another thing. So normal means somebody has to define what the norm is and the deviation. And in 1726, it suddenly appears with the sciences as an organized knowledge system that it's a difference between observed value and true value. And now we have still truth in all that. That makes it not easier. So, and actually when we speak today, we speak all about trial and error. And there's not a lot of thought about what error means in that and how much error should be allowed or not allowed in the trial. We speak also of risk-taking in research. So how do these things go together, and what is an admittedly allowed error and what does count as not one? So what we have to look at and think about and exchange over is that with the institutionalization of research, so with the fact that we have funded research institutions, we also invent this idea that they should be governed by norms and values. This is not something, when you had individual researchers, that was not something that was necessarily thought about. And these norms and values are, of course, changing with time. In a globalized research system, there are tensions. I mean, just look at the way we discuss what is allowed in some countries or not allowed in other countries when it comes to ethical standards in research. It's field specific. So if I come from the social sciences, interpretative sciences work very differently to what we just have seen, nanosciences or cancer research or whatever, physics, whatever you take. We have to think about the culture of research and critique as a central element. Then, of course, the word of serendipity hasn't come up. That is a much beloved word that actually we live from serendipity, from the fact that things just happen without our doing, but that we need to be prepared to kind of see the unexpected. And that's, I think, an important point to make. Now, if we take together all these classifications, we have error, and on the one hand, we spoke about uncertainty, we spoke about the honest error, whatever that exactly means. We spoke about lack of precision, we spoke about systemic or systematic errors, but I could also ask something like too fast publishing. We haven't spoken about the real conditions of research, that scientists go out and publish stuff that is not actually checked and balanced, because it's good for their career, it might be potentially interesting. That comes back to what you took as an example, the cold fusion. Actually, one of the big problems of the cold fusion was not only that they didn't make the checks and balances, they first went for a press conference. And then they tried to publish something, and that made the whole thing explode. But before even anything was checked, they already had the media present telling this wonderful story about energy out of nothing. And then on the other side, you have a lack of reproducibility. You have all the debates about fraud, fabrication, and falsification. You have the question of bias. And of course, we all have bias, but what is an acceptable bias then? So, I mean, in medicine, for example, and in biology very long, we did experiments mainly with male animals. Then they went into the clinic and they made experiments with male patients because it was easier, because science was more precise if you just took one category. And women have these strange hormonal cycles and stuff like that. That disturbs the accuracy of science. So we test on male animals, on male humans, and then we give it to females as a treatment. And then some die of it. I mean, yeah, that was an error. Honest. Was it? Okay, so bias. And that is really important when you go into medicine about false positive and negative results, because that matters to humans. And I think there becomes, and I think that has been pulled up already. So what we see here is enormous work, boundary work going on. What is still an acceptable bias and what not? How we are humans as researchers, so there is bias. The question is like, do we reflect it? Now, I just browse over that. There is a huge amount of debates about show me where your money comes from, the problems of that we need to embellish and promise all kinds of things. We have the reproducibility crisis. We have the complexity of experimental animism, and this is very nice, a paper about when mice mislead, which I like very much as a title because I think, I'm not sure that the mice mislead here anything, but they're complex and that leads that they don't always comply. Now that brings me to my last point, which I would like to invite you to think about, namely new challenges we are facing right now with this idea of data sciences, where we think the more data we have and the better algorithms we develop, the more we will understand the world. And I think we need to reflect what seeing and thinking the world through numbers actually means and through big numbers means. We always thought the world through numbers, but through big numbers. And I think to collect, store, retrieve, analyze, and present data through various methods means to bring the objects and the subjects that data speak into being. So they are not just out there. Data make what we see in the world. So we just do not see what is in the world, but we make what we see. And the telescope example was a wonderful one because it's a highly technical reconstruction of images. You don't simply see these things. It asks the whole science of seeing. So it's highly technically mediated through the use of huge amounts of data and reconstructive methods. So we just don't see straightforwardly by any means, and we have to ask what that means. And that brings me to my last point. We are in the middle of an algorithmic euphoria that we think that algorithms are better than humans. AI and other things bring us and say humans make these errors and other systems don't do that. Now we have to think what we trade it for. And I do think algorithms have the capacity to shape social and cultural formations in the future and impact directly our individual lives. It's not just about knowing, it's about being in the world. So they denote the new rules of rationality that replace, to a certain degree, the self-critical judgments of reason. And because we don't understand algorithms to a certain degree, or we have not developed an algorithmic literacy as a society, this is a very moment where we have to ask these kinds of questions about errors or non-errors and what kinds of lines do we walk across knowledge. Thank you.
Okay, so thank you, Ulrike. Thanks to all the panelists. Now you're going to have to defend your ideas against each other in a round table, which means that due to an error in design, we will be facing only half the audience and we'll be turning our backs to the other half. Yeah, so you're going to, exactly, in a maelstrom around us.
Yeah, and then turn the other way around.
Yeah. Or we can randomly rotate the chairs.
Wonderful idea.
Okay, so can I invite the panelists to come on stage? This is a perilous exercise. So we should have a microphone, yes? A microphone here. You're hooked. They're going to be, they're going to benefit, obviously. They have the first words.
There's some distributive injustice.
Yes, exactly.
There was more one.
Actually, there were supposed to be more microphones, so I'm going to hand this one over to you first, because I'm going to start out with you, Ulrike, actually, so that's why I handed you the microphone. You mentioned the problem of irreproducibility and of, well, how we evaluate errors in a scientific context. In fact, that problem has been solved a long time ago. You are certainly familiar with the Journal of Irreproducible Results, which has the motto, results that cannot or should not be reproduced. So this is the perfect solution to that problem. But I'd like to actually go back a step, take a step back, and go back to the definition of norm and deviation. Who's supposed to do this? The scientists? They say, trust me. Is that?
Actually, it's a... Does it work? Ah, yeah, now it works. Actually, I do think that is the role of the scientific community most of the time. In particular, also key actors like journals or other forms of editors matter a lot to what gets acceptable or non-acceptable in these environments. And so this is the scientific community. Editors are also part of the scientific community. So it's much a community issue than anything else. So of course then, because we have such a mediatized debate, sometimes this gets spread out into other arenas, and then it becomes complicated. Because we have very little knowledge about most people have very little knowledge about how research works. So how these things are negotiated and thought about, etc. And so suddenly you have these kind of debates which happen a bit in the nowhere about that science doesn't produce truth, and I think, like, did science claim that? So that is the difficulty. And in fact, because science is so much tied up with political arenas also in many fields, so we need to make promises that certain things advance us in whatever direction, then the standards sometimes get a bit, weakened, let me say like that, due to pressure. And I do think we see that in the reproducibility debate. You see that very nicely, that some of the stuff is only because it has been run once, and because it looked like a great result, it just gets thrown out. So I think the scientific community and the policymakers are called for to discuss these kinds of things.
But what about society? We're talking here about norms. We're talking about deviance from norms. This often affects the public in general, not just the scientists. So as long as the scientists are talking about their own field, that's fine. But what about when it starts affecting society overall?
I mean, sorry, maybe.
I'm just launching the question, so whoever feels that they would like to answer.
I think as a scientist, we are part of society. I would not, regarding that question, I would not say you are a scientist or there is society, and then it's getting more relevant. It influences how you're dealing. So.
Ulrike.
Yeah, I mean, of course we are part of society. But on the other hand, if you're a scientist in the system, what counts are the rules and the system plays. And in that sense, you might sometimes overrule what you might think as an individual. I've done a lot of interviews with researchers in my research work, and it's quite fascinating that they say, I would never have published that at that point in time, but I knew that there were other competitors out there, and my university is totally keen on getting a first, so I publish it, and I think that happens all over the place. And so I do think they know that maybe it's deviant from certain kinds of norms, but there are advantages for them, and so they trade with it. And that differs from field to field, and the biosciences struggle quite a lot with this kind of competitive edge thing, whilst in part of the social sciences, this is just not the case, and there would be no reason to do really sloppy work, actually. And it happens also.
But Jim, you pointed out that we're sort of always evaluating against the specific, I would say, mythical normal distribution, which is very appropriate for certain environments, but not at all appropriate for other environments. How do you see?
Well, I think we have to actually change our concept to this, the bell-shaped curve, Like if you ask the average man or you ask the average woman, it's such nonsense these days, right? So, there's such a diverse, I think society is becoming much more diverse, and that's a beautiful thing. And as society becomes diverse, so should science become diverse. I don't think, the concept of the scientist with the lab coat, right, and safety glasses. I think scientists today, you know, should have a breadth interest. They should interact more with the society. And, you know, just getting the number right doesn't mean much. When that number, what does it mean, you know? Particularly in network systems. And that's where, you know, biology, for instance, a network system. So the concept of an average is meaningless in some respects. So you can spend all your life measuring this average, but the diversity and distribution of systems is what's important. And if that's important, we should also be diverse. And we should use, I mean, I think artists have always been diverse. You know, if you say, well, what, you know, if you ask the average artist, you're nonsense, right? Ask the average artist what he thinks. Could we see the average artist?
Yeah, everybody who's an average artist in the hall, please raise your hand.
And increasingly, I think the concept of the average, you know, scientist and some, you know, like some idiot in a laboratory that's just, you know, doing the same thing and working out, trying to minimize the standard deviation to get a more accurate result. The good example, you know, I gave that example of the ultraviolet catastrophe. They said, we know it all, we're just adding zeros, you know, to the constant. And suddenly, boom, something came out where there was this, you know, when we talked about standard theory, right? Mm-hmm. Apparently, you're saying every experiment works out perfectly, but theory's obviously pretty maybe wrong, you know, in some way, but you can't prove it's wrong because you get the same result every time.
Yeah, so this is sort of seeing the error as the carpet under which we sweep our ignorance on one hand.
Yeah.
Ulrike, you also said that there are no more monsters. Scientists have banned them. But in that case, with this particular view, actually the monsters are still there. They're just hiding in the error bars. We've caged them in the error bars, but they're still there because this is where the new unexpected results should come out. We have a good theory. We compare what we measure to our best theories, and we see no deviation. But
where's the dark matter?
Exactly.
You know?
I just would like to add a big but. I fully agree with what you say, but the way how people can act in this research system is just not evenly distributed neither. So certain people have more possibilities to do what you think is the good way to go, while when you're young in your career, you're exactly asked to very nicely behave along quite standard trajectories to get into the system. And once you're in the system, you can produce the story that it doesn't matter, and I can produce that story, but for young people it actually matters if there are norms and if you need papers and if, I mean, I think we should be honest about that.
Well, I think that's fine. You know, if you want to be a sushi chef, and I'm sure you can comment on it, you have to do the dishes. You know, you have to clear out the trash, and maybe you do that, what, 20 years, and then you move your way up to be the sushi chef. You know, it's a process. And the sushi chef can then, you know, he can do fancy stuff and so on. But, you know, you have to clean the dishes before you can become a chef.
But the question then rather would be why those people that are in the system already don't make the changes. So that's actually what I'm asking. Why do those that are very well settled in the process are usually not the ones that are the drivers of the change?
Well,
but very often
I wouldn't agree. I wouldn't agree. I mean, you know, students in my group are encouraged to do, you know, very diverse things. They still have to wash test tubes. I don't use test tubes anymore, of course, but, you know, and, you know, I encourage them to work with, you know, artists. Every you know, there's a diversity in approaches. And some students just want to have a professor who's very strict and, you know, and some other ones want freedom, but a lot of students don't really want total freedom. You know, they want direction and guidance.
But we're still assuming that for research that there is a truth out there, that there's something that can be unambiguously determined. But is that really a good model? I forgot who mentioned.
I disagree.
Yeah. Go ahead.
Okay. I think assumption that something we call truth exists is very dangerous. Actually, I'm very inspired by Jim's talk, also Mike, your talk about physics. Physics is understanding universe. I'm tempted to believe there must be certain truths. But science, which includes people or society in a loop, is totally different beast. Late Professor Marvin Minsky, he's the father of AI, said students say, study real science. Real science doesn't have science in a definition, like a computer science or social science or human physics, chemistry, or mathematics, those stuff. But once people in a loop, my field is human-computer interaction. It's very fuzzy. We present in science statistically significant results, but when human subjects in a loop, it's so difficult to predict anything. Also from people to people, totally different cultural stuff. So we have to really celebrate non-existence of the norm or perfect answer or truth or average. We have to take diversity very, very seriously. Once it's open science, people, society, cultural stuff, I think that's a really interesting challenge of deviation from traditional hardcore science of studying nature, principle, to the more chaotic but exciting science.
I mean, we have data. All of the philologists also have data. And occasionally that data is unambiguous. You can read a text. But then how do you interpret this text? There's a nice example from Archimedes, who talks about the astronomer. Friedrich Blas in the 19th century was trying to understand a text by Archimedes, talking about his origins, his naturalistic origins. And there's a text written by Archimedes which says, the astronomer Phaedia to Akupatros, which is Phaedia from Akupatros. Okay, that is ambiguous. It means something, but nobody knows Akupatros. There's another reading which could also be used, which is just to divide the text differently, which is Phaedia to, sorry, I have to find it here. Phaedia to Amupatros, which is just a transcription error in the past, and which means Phaedia, my father, the astronomer. Same text, same data, totally different meanings. How do philologists deal with this kind of fragmentary and diverse data that they have to then try to interpret somehow? What is truth in that case, and what is error in that case?
That was a little bit what I was thinking about certainty and uncertainty. We do not know quite a lot of how things were interpreted at certain times, or at least that's how I address it. And then you have to think about the concepts that were related to the time. And you have to be aware that it is always an interpretation that you are doing. And that's probably as well a starting point, a new starting point in our studies as well, and can more easily be opened by digital humanities as well. Because then you could as well show diverse views on the same text, which are for sure available and diverse interpretations of it. And I think that's quite relevant, to be honest.
Diverse views of the same topic, interpretations. I think we're sitting straight in the area of fake news or alternate realities, alternate news. And this reminds me a little bit of the dream state in which we are when we're dreaming. Everything feels real. There's one clear, unambiguous answer. And yet, when you wake up, you realize that it's all wrong. Can we learn something from the way we handle dreams on how to deal with interpretive variability in society? Science tells you what's clear, but
I think culture has often looked at sleep through the lens of dreams and seen the dream, because it's most like what we take to be culture, as the key thing that it produces. I think what we're interested in is looking beneath the level of dream, at level of the physical, chemical, hormonal, neuronal activity of sleep and sleeping bodies and sleeping practices as being diverse. I think the question of fake news also is something that is too dichotomous in a sense. I think if media studies was to be a discipline that would work alongside things like philology, we'd also see that news has always been fake. It's always had certain degrees of perspective built into it. So media and the assertion of truth is always a statement of power in a certain way. And the question is developing an art of enrolling and enacting power in a humble and open manner, and not in a demagogic manner. I think this is the way of dealing with the question of truth or fake news. But part of this is also of learning to treat very carefully the problems of naturalization that science tempts us with. We've had diagrams shown in this presentation that establish enormous degrees of equivalence between very, very different kinds of system. And these are very powerful because they allow us to generalize. But once they allow us to, or encourage us to think that things are natural, that are not open to reinvention, there's also a great risk of not understanding the context we're in. One of these, obviously, is the economy. So when we start thinking about the economy as something that bears relationship to natural phenomena, because the optic of numbers allows us, under certain perspectives, to interpret them as having certain kinds of equivalence, we lose the capacity to reinvent the economy. This is what is causing some of the present crisis that in turn generates fake news. So we need to think about these as kind of interacting scales of complex systems, but without reducing those complex systems to something that we can take as nature and that which we can't intervene in. The economy is precisely where we need to be thinking about.
Ulrike, I saw you nodding. Do you want to?
I mean, it's an interesting question how the social sciences, for example, should communicate what they know about the world. And I think we haven't used one vocabulary, and that is plausibility. Some interpretations are more plausible than others because they manage to tie together different phenomena in a more stable manner than in others. But we have to make, and that's why the methodological debates are always very high in the social sciences, where you have more standard methodologies in many other fields. The method debates are really, really very important. So how can I say something about society? What would I need in order to make a credible statement? Because we are very much aware that, as you said rightly, we handle people that are in themselves extremely diverse, and it's very difficult to extract information from them because we have to rely on what they are ready to tell us, and that is our measurement technique. And I think the social sciences need to communicate that maybe more explicitly and to kind of open that up and maybe argue through showing that certain combinations are more plausible than others, but we don't speak of truth in any way. This is something that comes out of a particular understanding of the natural sciences.
Social scientists, though, they try to, social scientists try to, I mean, in my opinion, like humanities in general, they try to look from a distance at what's going on, and they don't want to be part of it, and they believe it's a, but everybody, it's like quantum mechanics, the observer is always changing the system. And I always find it weird with the humanities in that respect, to the way they don't want to be involved. And so maybe they're missing out on something. Maybe they should actually be part of it, and then maybe they would have a slightly different interpretation.
That happens a lot.
Yeah.
I think the metaphor of particle physics versus thermodynamics, zoom in, zoom out, distance, seems something interesting. If you want to deal the mass as a more objective stuff, you have to zoom out, but then decouple the realities. I think this axis seems something very, very important.
Yeah, well, zooming in and zooming, I mean, I work with atoms and molecules, and, people, I used to think this microscope is a tip and a surface and a molecule. We look at a single molecule, but we don't look at a single molecule. We look at the interaction of the molecule with the surface and the interaction of the tip of the molecule and the interaction of the tip of the surface. So we look at we're actually looking at, like in a Buddhistic sense, the atom does not exist by itself. The atom is always connected. Your atoms, they're connected to the environment, right? And so the concept of zooming in, even though you zoom in, you're still connected to the stuff that's outside where you're zooming.
I think you mentioned the powers of 10.
Yeah.
Powers of 10 is a great example. Also, Mandelbrot really found the fundamental truths, mathematical truths of many different layers. So maybe Ars Electronica is a great place to find some zoomable unified theory to bridge all the particles, people, society, and all the political, social agenda.
And it would be a kind of chaotic, self-organized system full of avalanches. That's what it would be, right?
Yes.
It would be totally dynamic on every time scale.
Yes.
Yeah.
I was going to go into the temptation of going for simple answers, of going for the particle physics view of the world, and contrasting that with artificial reality and virtual worlds and so on. If you want to say something to that, the temptation when we play with artificial worlds, video games, they're clean, they're aseptic, they're not as messy as reality. So it's easy to want to escape reality into those worlds. If you play a game, you die, you start over. In real life, it doesn't work like that. You play, game over. How do you make artificial worlds real, grotty, rough? Smelly, exactly. Yes, I want to breathe in my virtual reality.
First of all, try to make artificial world, like a game world, virtual world, real. It's a long goal, long assumption. It's not real. Important thing, truth is something important. All of us are mortal. We are dying. We are afraid of dying because we are afraid of being forgotten. No reboot buttons. So game may give a long idea, long value system, which is okay for having fun. But fundamentally, if we talk reality, it must be grounded. It's the real truth. I saw that many people in 2011, the earthquake and the tsunami hit Tohoku in Japan. The people in Fukushima lost their home because contamination by radioactive 2011. They are banned to go back to their home. It's so crazy. But the people really so sad because people almost forgotten after 7 years. So don't forget. Also, my dad was a soldier of Japanese army, fought against Russia in Manchuria, then captured at a prison in Lagery, Siberia. He survived, but so many of his colleagues died, and all their colleagues said, please tell my family, friends, I was here. Don't forget, means don't repeat the error, mistake. So those are important truths. So I care game, but most important, what's the truth? That is the core of the reality.
Okay, so since we've touched on a rather dark subject, no, it's good. I wanted to come to the darker subjects in any case, because we talked a little bit of fraud. We talked a little bit of the temptation to take shortcuts. We always assume malevolent intent, but who's to say that Dr. Jekyll is even aware of what the evil Mr. Hyde in the unconscious is scheming? How can we act so that we can, on one hand, detect fraud, and on the other hand, minimize it, see when errors are being made intentionally or unintentionally? I think it's to either of you.
I do think this question is a fundamental question to how we socialize and how the social works in science, actually. How do we deal with transgressions? And I think that's an important signal. And I think for a very long time we have just silenced it because it disturbed the ideal picture of science, and we didn't speak about it. And when you think about many cases in the 70s and 80s, nobody spoke about it. In the German case, people were they were told to leave the university, they were given a nice letter of recommendation, and they went to the next place and did the same thing. It's very recently only that we started to really unpack these things and to also speak about the conditions why that happens and why it is so difficult to speak about these things. And here come power relations into play. possibly in your group that works quite well, but I know many other groups where that doesn't work so well and where hierarchies matter enormously and where you would never contradict your boss, even if you know that's stupidity and it's nonsense or whatsoever. So the system is a quite stratified and hierarchized system that not invites, I would not say that, but that kind of prepares the ground to maybe imagine that you go beyond. And I'm not even sure that people are aware sometimes, because it's a slippery slope. You don't check your data and it goes through and etc. And to come back to the interviews I've done, a couple of young people said me things. My boss came 3 times and asked for the data, and the 3rd time I did not dare to tell him that I have not finished checking them. So I gave him the data, and then I was shaking for 2 weeks when I was controlling them that they are the data I could give away. And so it is a quite interesting story. So this is a real life experience of young researchers, and not just, and we have as a system to speak about that and to address it, because that's the only way how we can keep the trust in the system. It's to keep the checks and balances.
But I kind of think this is, somewhat wrong. Basically in science, the amount of fraud that's committed, is minusculely small. Okay, there's a case where, maybe a student is pressurized and makes a mistake, right? That's a communication error. It's not fraud. But in cases, there are a few cases of fraud in science, but in general, it doesn't exist. Look at politics. It's based on fraud. The whole concept of politics is just a massive fraud. Look at businesses, CEOs. It's massive amount of fraud. Look at them. I would say, look at the churches, the fraud that goes on in the Roman Catholic Church. Okay, abuse of children. That is massive. But to now say, now we're going to look at science and there's a fraudulent professor in some corner, I don't think it's worth discussing. That's my opinion.
I don't share, that's wonderful. I don't share that at all. I do think there are a lot of social problems in the system. We discuss a lot about bullying, about pressurizing, about not giving credit to people. This is fraudulent behavior in science. I'm sorry.
I think I wouldn't use it. I wouldn't use the word fraud, though. I think there are certainly problems with the system, and they can be improved. But my thought of fraud is more of the whole political system that which control the scientific system, which give out the grants that result in situations like you're talking about.
But look, any social system has malfunctions, and they are always in a lower degree. So, if you would look at the normal legal system, you would only find a minuscule portion of people transgressing the norms.
Not in America.
Oh, maybe. Okay.
Just look at the news recently.
Okay, good. But maybe we have to calculate that per population. Okay. I don't want to take America now as the example for anything. But I'm sorry.
That's okay. No, I don't mind.
But I do think this is widely debated within the scientific community. Just look at the key journals. It's all over the place because we have to address it. It's not the number of people, and it's not the fact that it's found out after 3 years, but it's the problem like who gets into the big journals. How can it happen that somebody publishes 15 Science and Nature articles in 3 years and they're all based on no data?
You're talking about Schoen, yeah.
Yeah, for example.
And Backlog was his
there
boss.
Are a number of, so that tells us something, that certain control systems do not work as perfect as we pretend.
Nature is one of the worst journals in the planet Earth, okay?
Maybe can we add science
and if you look, it's run
others,
by young people, and it is becoming terrible. And they've had all these offshoots.
No. It's not about one thing being terrible.
In that case, it was the editors of Nature that were responsible, and they were under pressure to make money.
Profoundly social, and as long as it's profoundly social, we have to address these things. That's all I'm saying. It's not a question if it's a per mil or if it's whatsoever. It's a question that if we ask people to trust in a system and give us as researchers the leeway to creatively do the work we want to do, then we need to address also openly the problems.
And
we
how
have.
do you
That's
work,
all I'm saying.
and what are you doing about politicians? Are you involved?
Of course, we all say that, okay. I would largely agree with what you said about politics, but that is not the point. The point is not to say politics is worse.
But are you working in that field? Many people, if you look at
No,
everybody is looking
so
at
I'm
the
not working
scientists,
in
but
that field.
many people are actually, you're frightened probably to look at the politicians.
No, I don't think that's the point.
We're
No?
not doing her justice
Okay.
in this case.
I'm quite outspoken about a number of things.
definitely.
So definitely I don't shy away from also saying what is to be said. But I do think as a science system, I'm not saying it's corrupt or anything. I'm saying if we want to have the freedom we aim for, if we want to do the research we think is sensible to do, then we also have to address some things that do not work in an open manner. And I don't think...
But I don't think social sciences will improve science. I think science is a diversity, a natural diversity. And, you know, somehow I get the idea the social scientists are looking at it again from a distance. And, you know, we can improve this bunch of monkeys that are running around in the laboratory, you know. And do you live in a laboratory?
I've been working much longer with scientists than you think, and I have
Okay.
done my PhD in physics, so I know a lot about the field. I don't need to make that claim, but so it's interesting that you take away the expertise from social scientists to look at other fields. Why not? I can look at politics, so why could I not look at science? And why would it not be good for science to have the conversation with the social sciences? This does not mean that we know and you don't know, but that means that we might see things from the outside that you might not see from the inside.
Well, I love having conversations with artists and working with artists. I've never had a very good experience with working with the humanities, but that's just personal.
That I would not have guessed that from your reaction.
Maybe I can take this in a little bit of a different direction now, because you're sort of arguing the case that self-policing does work to a certain extent, which is good, and I believe that. But there's a downside to the self-policing as well, because the self-policing means that the norms within that group are going to impose. And one of the norms that we have within science is an intolerance of error, an intolerance of failure. And so we need to have some way to encourage a change of that norm. Maybe you can say something.
Yeah, I was thinking about that as well. That is, I mean, and it's probably, we are talking about failure because it is relevant for business companies as well, because they are looking at that from a productivity way, and they count it in money. And if they count it in money, it gets into a different direction. We would not do that in the sciences. In the sciences, and especially in the humanities, we would not look into that. We have the people that are hired, and they are doing their job, and we think they are doing it in the best, and they are doing it in a way where we expect it from the system. And that was actually what I was thinking before, and when I was saying, you're as a person part of society as well. And if you are scientists, I would expect if you are in a higher, let's say, hierarchical level, we could change the system. And we should do that if we are aware of it. And especially if we are intellectuals, we should do that, and we should try in our research groups, in our institutes, run a different way of failure culture and map it to more productivity and open it up. That's the idea behind it.
Well, in the case of Schoen, you know, that was at Bell Labs. And I think Capasso is a friend of mine. He actually brought together everybody and government, the whole thing, and they tried to look through the whole issue and try to, you know, identify how did this happen? How did this happen? And they made, you know, all the efforts they could. And it's the weirdest. I mean, that particular case, it was the same graph was published time after time, and no one, the referees nor the editors in Nature, seemed to notice it was a different molecule but the same graph. They hadn't even changed the scaling, you know. I think that was due to, that was something to do with a person having mental problems. And if you look at this room, probably 10% of the people in the room are mentally disturbed in one way or another, you know?
No, raise your hands, those of you who feel addressed.
Statistically, you know, or on heavy, you know, pharmaceuticals that are designed for, you know, depression. There's a lot, in this room, there's a large number of depressed people.
Okay.
Getting more depressed by the minute by this pedal.
Yes, absolutely. So there are two things that we can do now. Either we can wrap up the panel because we're coming to the end of this session, or we can ask these 10% if they would like to ask us a question before we finish. So there's one question over there, and a microphone will be brought to you in a second. There we go, because we reserved one microphone specifically for questions.
So I'm curious, as the paradigm changes and we see what was error before and now is something that's the truth, how do the sciences in particular go back into the era where all these women participated and they were not there, and we're slowly finding out that they're re-emerging? Is there an effort to do this, to look into the past and rectify it, or change it, or throw a light into what was considered an error in the past?
I think, Ulrike, you're the one who probably knows best about this.
Actually, I should have said I wanted to address it to you.
Thank you. Actually, I do think, if you think in terms of errors, I think we can learn from history and from a good analysis of history. I mean, because it shows you very nicely what kinds of values made us do and make certain choices. But that is often not very easily translatable in the now, and I come back to you, because of course we are in a value system. We are grown up in a value system, and then these value systems also get performed in the science system in particular ways, and this is inescapable in some way. So I think it's very often to stop and think, when we see that certain tendencies emerge, that we start to think about that. And sometimes I use historical examples, and then students say to me, yeah, but that happened 150 years ago. This would be impossible nowadays. And then I remind them of the study by Wandl-Vogt of the peer review system in the, I think, Swedish system, where they gave away stipends, and they very nicely showed how many kind of ropes of relationships mattered to science, and how that disadvantaged women, for example, in a kind of outrageous way. But, learning means that we check regularly how we do things and how we think about them. And we are touched by that as much as any other. The social sciences are in the same way, in the same boat, in the same problem area. Maybe just that we have built in to more explicitly make our position from which we speak, which has actually historically been wiped out in the natural sciences. When you go back to older texts in 18th and 17th century, you still see the scientist that explains how he came to an idea and with whom he spoke and etc. That has totally been kind of wiped out. And I think maybe we get some of...
There's a long way to go, though. And I think it's been deplorable the way women have been treated in the past, and even, Nobel Prizes and things like that awarded to men when the woman was doing, a lot of work. Even if you take Einstein, and his work, it was a woman. Women had a large influence on it. And I think you should also, include the LGBTQ community, that should be represented in such a, in modern science.
I mean, we generally are very good in reinventing inequalities in new ways. Society as a whole, this is nothing special about science. And so we have different kinds of inequalities now than we had maybe 100 years ago. But it's a learning, I think, and that's why we should remember these things, and history matters. And I think many examples were historical examples exactly because we can kind of look at them with a fresh perspective, because we are not in that value system anymore. But that doesn't, sometimes we don't go far enough and pull us. We have to kind of out of our own imaginations.
Unless there's one other urgent question, which is the last one,
Hello. It's on? No, thank you. I want to ask a question about complexity and behavior. And I'm very interested in ways in which artists and people who are actually learning science can represent this level of complexity. And my question is really about how can we, as artists, help to communicate that complexity?
Jim, this is a lob ball at you.
How can we communicate complexity to younger people? I think you have to start at the very early age, and I think the problem is they get brainwashed into this reductionist kind of view to the extent and that they just are brainwashed and they can't accept the natural world around them. So, in a way, I'd like to get rid of teaching and just have, inquiry-based learning. That's the way I work, and encourage them to understand that the world is very complex and these mathematical formula that we use for, two-particle interactions and so on, they're good for you, but they're not good for 99.99% of the world. I think encouraging them at an early age with art and music is really important. In American schools, to save money, they talk about this ridiculous concept called STEM. It's the most disgusting process in the planet Earth. It has no art in it, it has no music. It's destroying creativity and open-mindedness. And I think one of the first things to help with this process is to completely eliminate every STEM program in the United States. That's my opinion. It's like sticking them in the army,
I think this is a good final word, actually. You want to add something?
Yeah, I think maybe there's also, in the way that the question's posed, you might rethink some of the presumptions that are in there. I think art is not about representation, and the job of artists is not to communicate. Yeah, but I think that since the end of the 19th century, art in the modern and contemporary sense is not representational. It's about action in the world that produces knowledge, experience, sensation, and so on. And this is why it has an affinity with sciences, but it cannot be reduced to this question of information transmission.
Also not a bad final word. Okay, I think with that we should wrap up now. And I thank everybody for having attended and for the panelists for having contributed so wisely. Thank you.
Very good.
Space art start in 22 minutes. So hope all the speaker can test your machine. Machine may betray, technology betray you. So please make sure. Oh, I have to.